So let's take a look at the eye anatomy. I give you fair warning, I'm a terrible artist, so the drawing is going to be absolutely awful, okay? But I have to subject you to this kind of torture. It has nothing to do with reality, okay? Shape-wise. So the eyeball can be divided sort of. First of all, the eyeball is surrounded by 3 layers, okay? The outermost layer of an eyeball okay, this is a fibrous layer. So fibrous layer consists of sclera and cornea. Now, you can see that in this drawing, there is sort of a larger kind of circle. You see what I'm saying? And a smaller bump in front. So that larger circle is sclera, and the smaller bump is cornea. Okay? So sclera is the white of an eye. It is very, very tough. It is basically a continuation of dura mater. Dura mater, as you may remember, is the outermost meninge that surrounds your brain. Now, cornea here is the transparent structure. Sorry. And it is refractory. Okay, now refractory means that it can change the direction of light. Just like your glasses or your contacts help you to focus light into your eye, this is what cornea does. It focuses the image. Are we clear? However, you cannot change the shape of the cornea, therefore, doesn't allow you to kind of closer, farther vision, just refractory. So cornea is covered by stratified squamous epithelium on the outside, which makes perfect sense because it is open to all elements. And on the inside, cornea is covered with simple squamous epithelium. Here's an interesting thing. Cornea is not vascularized. There are no blood vessels. We will learn pretty soon how cornea receives nutrients. Am I making sense? Because if there are no blood, it has to somehow. So we're going to learn pretty soon how it does. And it makes perfect sense that it's not vascularized, because if it would be, you would constantly see the lattice of the blood vessels. Okay? And that also makes it fairly easy to transplant cornea, because if there are no blood vessels in the cornea, there is no immunological rejection. So you can take cornea from one person's eye and move it to another person's eye. There are eye banks. It's pretty straightforward. Well, not that I would do it. Next layer, is called vascular layer. As you can imagine from the name, one of the main functions of it is the blood supply. But not only this, now I'm contemplating how I'm going to draw it. Yeah, I'll take it. Okay, so there are 3 fairly distinct parts. This one, kind of that runs in the back. These ones, I'm going to make these things here. going to be 4, and this one. So we're going to start with number 3. It's called choroid. In the models that you're playing with, it's that brownish layer right here. That's choroid. Okay. So choroid plays a crucial role in supplying blood to the retina. It also is essential for light absorption. Now let me clarify this. So your eye, the sclera, right? The sclera is white. Look, it is. So now look at this not unfinished picture. When light goes into your eye through the pupil, I'm kind of jumping ahead of the train here, but it goes through the pupil, right? And it reaches the depth of an eyeball. If it would hit the white sclera, it would start reflecting from it, and it would start scattering within. Does that make sense? You don't want the light to bounce up and down like a little, bouncy ball. You want this light to reach the end of the eye and be completely absorbed. And choroid, with its dark color, allows you to do just that. Okay, makes sense? So far, good? Okay. What is number 4? So number 4 is ciliary body, which contains ciliary muscle. We're going to talk about it, what it does, and ciliary capillaries. Now, these little thingies are so-called, these ones, called ciliary zonules, and we're going to talk about lens closer to the end of this conversation. So they basically hang the lens. And finally, number 5 is iris. Okay. So number 5, the iris, consists of 2 smooth muscles. In the center, it's basically a ring, and the inner part of the ring is ring-shaped or circular muscle called sphincter pupillae, and outer part is the radial dilator pupillae. Does that make sense? Now, I think you will understand, the function of these muscles. Sphincter, as any circular sphincter basically is the circular muscle. When it contracts, look, when it contracts, it narrows the pupil. Okay. When it relaxes, it opens up the pupil. Okay. Dilator pupillae, when it contracts, it pulls up the edges of the pupil, expanding it, and when it relaxes, the pupil goes back. So these 2 muscles allow you to regulate the size of the pupil and therefore the amount of light that reaches the inner part of an eye. So far, so good. Now, a third layer will be retina. Well, technically speaking, it's called neural layer. Now, I'm going to make just like this. Okay. So it's a neural layer. Neural layer, and I'm going to give it just one number. It's going to be number 6. It consists of 2 types of cells. We're going to talk in much more details how it is organized. But it is organized of the pigmented layer. Now, let's start now. Let's start with retina. Okay. I'm going to use a very fancy term, and then I will explain what it means. Okay. The fancy term is light transduction. Now, let me pause with writing for a second and explain what transduction means. In regards to special sensors, the word transduction means the process of converting whatever signal into the nerve impulse. Does that make sense to you? So when you see something, it's light that comes into your eye, but you know that I don't know, there's sun outside, or that the color of those muscle men is mostly red because your retina absorbs light and manages to convert it into some kind of a electrical signal in the nerve. Does that make sense? When you taste something, it's the chemical that interacts with a receptor, for instance. But that interaction results in nerve impulse. This is, again, a transduction. So term transduction means conversion of whatever stimulus it is into the nerve signal. Are we clear on the term transduction? So retina performs the light so this is basically, if retina is gone, you can't see. Everything else may be completely functional, you can't see if retina is gone. And then there is a pigmented layer within. Now, a pigmented layer, it supports retina, and along with the choroid, absorbs light. So it's, pigmented. So far, any questions? Yeah, I think it's pretty straightforward. Now, we actually have a couple more structures to add here, and I apologize, I didn't think well, and I will have to erase, and you can't do that. Well, maybe I will not erase it. We'll see how it goes. So one structure that we need to add, obviously, is lens. Okay? So lenses are located here. They are biconvex. So what their function is, refraction of an eye. Refraction of light. And they are responsible for what we call accommodation. Accommodation means that they can change shape, therefore you can look at something far and you can look at something close. Does that make sense? You all used microscopes, you probably all used binoculars, maybe once in life, maybe more. You know that you use microscope to look at something extremely close, but then you look binoculars or telescope to look at something very, very far. And you use different set of lenses in each case because of the distance. Another structure that, this is the one that I forgot to mention, is optic nerve, which is kind of important, So optic nerve, now I'm going to do this. So these black lines represent sort of the cover, the connective tissue cover of the nerve, the epineurium. And these blue lines here represent optic nerve. I mean, I'm not going to talk about what it does. Obviously, we discussed that. It conveys, so in the models that you're holding, the optic nerve is here in the back. Okay. What's important to understand regarding optic nerve? I already mentioned that the structure inside the eye that allows you to see is retina. Okay? Here, you see there's no retina. Can you see that? Like there is no retina. So this little part over here is called blind spot or optic disc. Now, from a completely logical standpoint, if you have part that has no retina, you should have a tiny black dot in the back of your eye every time you look at something. This doesn't happen because your eye is constantly moving. Okay, does that make sense? They're constantly moving, so you have a lot of images that overlap, and your brain basically compensates for the lack of retina and just builds in the information. This is why I don't have that blind spot. So far, good? So let's. I'm trying to think how to. Yeah. So we're gonna do a really awful part of this conversation. We're gonna talk about different compartments in the eye. This is just terminologically confusing. Okay, this is something that you just have to memorize. Okay? So lens, here. Divide the eye into the anterior segment and posterior segment. Does that make sense? So posterior segment, this part, also known as vitreous chamber. I know it's confusing. People who name things have their own place in hell. Is filled with vitreous humor. Okay? Vitreous humor is gel-like material. It's formed during fetal development. It stays with you for life. Clear? From clinical perspective, what is the importance of all that fascinating story about vitreous chamber? Turns out, this is what's called immunoprivileged site, one of several immunoprivileged sites in your body. What does that mean? Your immune system does not have an easy access to most of this space. So far, so good? The implication of this is that there are certain diseases, there are certain infections that really like to get into that part of an eye. One good example of this is, I want to say that it's Filaria canis, but I'm not sure about the exact Latin name. So basically it's the roundworm that normally infects dogs, but it can be acquired by humans, mostly kids that play with like crap, okay? And it finds the perfect spot in the eye. And kids can see it, literally. There is one episode, disclaimer, House MD is the great show. It's not often medically accurate, but probably the most medically accurate show on TV. There is an episode about the autistic boy who draws the wavy lines. This is taken. There are multiple cases of this infestations. It just probably just made it overly dramatic that he's autistic. Okay, but yes, since it's immunoprivileged sites, those worms have a field day. Okay. Now, what about anterior segment? So this is interesting. Turns out that ciliary capillaries here in the ciliary body, they produce what's called aqueous humor. Now, this is the watery liquid which contains, now lo and behold, it contains oxygen and nutrients. So aqueous humor essentially supplies oxygen and nutrients to your cornea and to your lens. Lens is the cellular structure, it's cuboidal epithelium. Okay? Does that make sense? Now obviously if you have ciliary capillaries in the ciliary body that produce aqueous humor, it's got to drain somewhere. Makes sense, right? So it drains right about here. It's called scleral venous sinus. Okay? In some people, unfortunately, these scleral venous sinuses can become either constricted or obstructed in some other way, so that drainage of aqueous humor is impeded. Are you with me so far? If it's impeded, it starts to accumulate in your anterior segment. Are you following? As it accumulates, the pressure in the anterior segment increases, and this pressure is sort of transferred onto the vitreous chamber, into the vitreous humor. And vitreous humor presses on the retina. This condition is called glaucoma. Constant pressure in the retina results in the damage to the retina and a continuous reduction of the field of view, basically. If it's left untreated, it can result in blindness. You can treat it by opening up the scleral venous sinuses, either therapeutically or surgically. Any questions? Okay, moving on. I'm going to throw some diseases at you, like clinically. Turns out that the anterior segment is also separated. This is why I say that, taxonomists can burn in hell. We've got two chambers. Anterior and posterior chambers. Okay? I'm clearing my conscience. There is no really physical. We can describe anatomically that aqueous humor is produced by a ciliary body, fills the posterior chamber, then drains through the pupil into the anterior chamber, and then drains into the scleral venous sinuses. But these compartments are, that's what we named them. So far, so good? Now, lens, I already mentioned, the cellular cuboidal cells divide and divide and divide, and they produce protein called crystalline. Well, and that they transparent, obviously no blood vessels there. Now, what are the two basically diseases, quote unquote, associated with lens? We're going to talk more about the problems with focusing, okay? But one that I'm going to mention right now is cataract, okay? A lens becomes claudicated. It can be congenital, but with age, that's normal damage. Nobody really knows what causes it. It's associated with oxidative damage, with sunlight exposure, obviously smoking, drinking, things like that. Absolutely treatable condition. Lens can be replaced by artificial ones. They work just fine. So far, good? Any questions? Now, a couple of last diseases for you to kind of understand what's going on. So since we talked about glaucoma, now it's a good time to talk about the condition known as papilledema. So in papilledema, basically in glaucoma, look, pressure goes from here to here, right? In glaucoma, the source of excessive pressure comes from the brain. Turns out, now this is something that sometimes is mind-boggling can be mind-boggling. If you think about an eye, how it's connected to the brain, essentially your eye, encapsulated into sclera, is the extension of the brain. Does that make sense? So like brain tissue grew out into the optic nerve and then the eye. Okay, they really continuous. It's kind of, it really is mind-boggling. So my point is that cerebrospinal fluid can penetrate into the optic nerve. So when intracranial pressure, cerebrospinal fluid pressure increases, are you following me? That fluid starts to leak into the nerve. And that pressure on the nerve then transitions into the pressure on the retina from the back. If you use the ophthalmoscope, you can see how optic disc starts to protrude within the vitreous chamber. We good so far? That increased pressure that's coming in this picture from the right, okay, damages the retina and also reduces vision. Papilledema, does that make sense? I'm gonna make a short list of diseases here, actually, kind of. What you need to know for disease, you need to be able to match the description and the term. Am I clear? So, things to know. Glaucoma, reduced drainage of the aqueous humor. Papilledema, protrusion of the optic disc due to the increased intracranial pressure. Cataract, claudication of the lens. One disease that I will never ask you about, because the name is self-explanatory, it's called retinal detachment. A hit in the head may result in the retina separating. We will learn more about it, but retinal cells, the photoreceptor cells, they can't live without oxygen supply. When they separate from choroid, they start dying. If you don't reattach the retina right away, it's toast. Make sense? So I'm not going to put it in the list. I'll tell you upfront. I mean, I'm not going to ask you about retinal detachment. It's just easier because it's self-explanatory. And diabetic retinopathy. Okay, now, what's the diabetic retinopathy? People with diabetes have really poor peripheral blood flow. So far makes sense? By peripheral, I mean smaller blood vessels, but people often focus on the problems with the circulation in the legs, for instance. As a matter of fact, they have really, really bad blood vessels in the eyes, okay, in the choroid. They become leaky, basically. That results in the retinal inflammation. And when retina gets inflamed, inflammation results in the formation of scar tissue. So basically, people consistently lose retinal functionality. Okay, leading cause of blindness among working age adults in the world. Now, interestingly enough, it's very, very preventable by regular visits to endocrinologist and optometrist, and that's it. So, like, if people maintain the blood sugar, insulin, all that kind of stuff, the vision can last for a really long time. Questions on this part? The functional anatomy, diseases, any questions here? Good? Okay.